Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches and class 6th students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 6th, our ongoing chapter number 5, heat. And today we are entering into the session number 4, probably the last session. So far we completed 3 sessions in understanding the concept of heat and temperature. Right? So we'll continue where we left in the last class. But before that, let us recall, let us review what we learned in the last 3 sessions about heat. Right? So just if you recall a minute, we started learning what is heat, what is temperature, right? And units of heat and temperature. Right? Again, in the pop of heat, we learned about the effects of heat. And after knowing about heat, so we have seen that branches deals about heat and temperature. So the branch which deals about study of heat is called calorimetry. A branch which deals with the study of temperature is called thermometry. Then we learn about the thermometers, which are how to measure the temperature. So we discussed about the various types of thermometer, various scales of thermometer. In case of types, for example, we discussed about the clinical thermometer, which is used for measuring the human temperature, human body temperature. We cannot use same thermometer for measuring the chemicals or measuring the atmospheric pressure. So different temperatures, the thermometers are designed as per the requirement. It may be named as clinical thermometer. It may be named as laboratory thermometer. Right? It may be digital thermometer, the latest technology. So we have seen how the clinical thermometer is made by using the mercury. Why mercury is used in the thermometer? Because of so special properties. After knowing, we discuss about the scales of thermometer like Celsius scale, Fahrenheit scale, Kelvin scale, and Römer scale. All the 4 scales we have seen. Along with the 4 scales, we have seen the relation between them also. How they are related, how to convert one scale of unit into another. We have the formula C by 100 is equal to F minus 32 by 180 is equal to K minus 273 by 100 is equal to R by 80. So this is a relationship for the finding out the relation, that converting the one scale of thermometer into another scale. Right? That's up to that we discussed in the last class. So heat is a form of energy which always transmits from high temperature body to low temperature body, or hot body to cold body. So a transfer of heat takes place from hot body to cold body until both bodies become same temperature. That is called thermal equilibrium. So heat, there are a lot of effects will be there. There is a physical change, there is a chemical change with the help of heat. When you heat any body, it may undergo physical change, right? Size, shape, dimensions will change. Similarly, undergo chemical change also. When you heat any chemical, It is gives us the new product. Okay. And the effect of heat only temperature. Temperature is the effect of heat. When you are heating a body, its temperature either raises or down, decreases, lowers. So the heat and temperature are relative terms. One is the cause, other is the effect. So clear? That is totally what we learned till yesterday, till the last class. Now when you come for today, what we are going to learn today? After completing about the relationship, we have seen here the relation between the various types of thermometers. C by 5, C by 100 is equal to F minus 32 by 180. That only they simplified. From here, it is simplified as this. Because they cancel here. When you cancel, you get this value. C by 5 is equal to F minus 32 by 9 is equal to K minus 273 by pi R by 4. Just cancel with this. Right? We got simplest form. By using this, we can convert any temperature into any temperature. Already I told you. For example, one wonderful question will come across. At what temperature the Celsius and Fahrenheit are same? The commonly asked question even in the every competitive exams. At what temperature the degree Celsius and Fahrenheit are same? At one particular temperature they meet. We don't know what is it. You can calculate. For example, let C is equal to F is equal to X, will assume. At temperature of X, they both are same. So we have to calculate the X. So what is the formula? As it is related to C and F, we can take C by 5 is equal to F minus 32 by 9. Because it's a relation between C and F only. So in place of C, we can take X. In place of F also, we can take X. So X by 5 is equal to X minus 32 by 9. Why you have taken X? Because what is the question? At what temperature the Celsius and Fahrenheit will meet or same. Right? This we got. Now go for cross multiplication. 9 into X. 9X is equal to 5 into this. What will get? 5 into X minus 32. Correct? 9X is equal to 5 into X. 5X minus 5 into 32. 160. Right? So 9X, bring 5X this side. It becomes minus 5X is equal to minus 160. So 9X minus 5X. 4X is equal to minus 160. So X is equal to minus 160 by 4. That is X is equal to 40. Means minus 40, sorry. So C is equal to F. Where it becomes same? Minus 40 degrees Celsius or minus 40 degrees. At minus 40 degrees, both Celsius scale and Fahrenheit scales are same. What we have done, simply we assumed that the Celsius and Fahrenheit is equal to X because we don't know what is it, where we are same. Clear? Like these questions can ask where Celsius and Kelvin are same. So you can let C by 5 is equal to K minus 273 by 5. Where Celsius and Roman are same. At one particular temperature, they'll meet with each other. So here, in case of Celsius and Fahrenheit, it is minus 40. At minus 40 degrees Celsius, both Celsius scale and Fahrenheit scale are same. Like this, so many possible questions will come in competitive examinations like Olympiad exams or any science exams. Okay? Or any competitive exam. So that's what we learned about the temperature. Now, the last part of the chapter so far. It's a very big part. We'll come across higher classes. Transmission of heat. Transmission of heat. What is my transmission? How heat transfers from one place to another place. Right. Suppose we have one iron rod, right? Iron rod. So we are one end we place the put fire, say burner, Bunsen burner with this. We are heating and you are holding here, right? One side you are holding. So we are heating here, one end, other end you are holding. So heat, what happens? Heat will transfer here like this. After some seconds, after some minutes, what do you feel that? Your hand is catches the heat. You feel the hot. We are not heating at this end. Even though we are heating the one end, right side end, the heat slowly transfers and comes to the other end. Simple, you can see the spoon. You place spoon in the boiling water for some time and touch it. Well, the spoon is not even directly contact with the one end of the spoon, last end of the spoon is not contact with the boiling water, but still heat transmits, heat transfers to one end to another end. So the transfer method is different in solids, different in liquids, and different in the gaseous or vacuum. Different methods are there for the transmission of heat, or different methods are there for the transfer of heat. Transmission is nothing but transfer. How heat transfers from one point to another point. We are saying now just when the two bodies are kept together of different temperatures, heat transfers from hot body to cold body. How it transfers? That is a method is there. That method is called transmission of heat. So this takes place the mode. There are three modes of transmission of heat. For example, you can see. You might have observed that food prepared becomes cool when kept in the long time. This is because of the heat passes from the food to the surroundings. The heat is transferred from the food to the surroundings. So heat is always transmitted from a hot substance to a cold substance. So when suppose take hot milk boiled after heating, boiling, you keep it on table for some time. So after some time, milk becomes cool. Why? Because the hotness from milk transfer to the surroundings and table also. You can touch and feel the table. When you touch the table, you feel that it is hot because the heat transfer from the milk to the table. That is our method. So the transmission of heat takes place in the following ways. Number one, conduction, convection, and radiation. There are three methods. There are three methods by which heat can be transferred from one place to another place. One end to another end. Either it may be conduction, or it may be convection, or it may be radiation. All these three we can see in our day-to-day life. Generally, conduction takes place in solids, right? Convection takes place in liquids, and radiation takes place either in gases or even vacuum also, space. So heat can transmit or heat can transfer from one end to another end by these three modes, these three methods in different states of matter. So we'll see what is conduction and how it is applicable in our day-to-day life, and what is convection, where this is useful for us, and what is radiation, how it is applicable, right? All these three one by one we'll discuss before ending the session, right? So first we'll start with the first method, that is conduction of heat. The process by which heat is transformed from one hotter end to the colder end of an object is known as conduction. In solids, generally the heat is transferred by the process called conduction. So heat is transferred from one hotter end to colder end. So where you are holding is the colder end, where it is the fire is there, that is hotter end. See here, when you are heating the any iron rod with one flame, so heat transfer from the hot body to cold body, and you can feel the hotness, and we leave the hand like this. Even when you are holding the any vessel, also we can feel the hotness. Right? So how does conduction take place? The substances are made up of many small particles. These particles cannot leave their own places. So example, see, when you take the iron rod, there are so many particles like this. In any solid, what happens? Particles are very tightly packed like this. So you are heating with candle. So particles, as in solids, the particles are very tightly packed. They cannot move. What happened? Suppose when you are heating this end, the heat transfers to next particle. Like that, there is a transfer of heat takes place till this end. As you are heating one end, and the heat transfer to other end without movement of particles. Very important. Without movement of particles. Because in solids, particles cannot move. But when you are heating, what happened? You can see here shown. The particles will transfer energy to next particle. And next step, come to other corner. Then we can feel the hotness. And we leave like this. Our hot hand gets burned. So such kind of transmission where transfer of heat takes place without actual movement of particles is called conduction, which takes place only in solids. Right? Clear? They take place only in solids only. None other than solids. Only this process takes place in solids. So we'll see some applications. What are the applications here? Right? Where they are applicable. Where we can see the conduction process. So many examples are there. See here. One. Cooking vessels. Cooking vessels are made up of metals so that heat is connected through them and passed on to the food being cooked. We'll heat generally cooking vessels are made up of either stainless steel or aluminum or silver, which are good conductor of heat, because when you are heating them by placing on gas stove, when they heated, they supply heat to the food and makes the food to cook, right? Copper is a good conductor, copper. So copper bottom vessels are used for save time and fuel. So copper bottom, you might have seen, we get the vessels with copper bottom. Why you use copper bottom? Because copper absorbs the heat fast, become very quickly, and makes the food to heat quickly, so that you can save the time as well as we can save the fuel also, gas. When compared to the steel vessel, copper is a good conductor. So we'll use the copper bottom vessels for the preparation or cooking of the food, because there is a fast transfer of heat takes place. Fast conduction happened in the copper vessel. Next, mercury is used in thermometer liquid because it is a good conductor of heat. Right? Compared to any liquid or any solid, mercury is a good conductor. So we'll use mercury in a thermometer, because when it is heated fast, it raises. The constriction will raise and shows the temperature. Already we discussed. Third one, automobile radiators. If you see in cars, when you travel for long distance, they become heat, and you get some smoke also sometimes when it becomes more heat. Every four-wheeler carries the radiators where we need to fill the water to cool them. It's called coolant. Right? So see, automobiles radiators are use tubes to made copper. They are also made up of copper, as it is a good conductor of heat. Being a good conductor, it absorbs the heat from the hot water from the engine and transmit it to the surroundings. For the same reason, air conditioners and refrigerators uses the copper tubes. Because copper is a very good conductor of heat, we use the copper tubes in air conditioners and refrigerators, and also in the radiators of automobiles to avoid the damage. Then heat is passed onto the solder through tip of the soldering iron, which is made up of copper. Some metals is soldering iron, where the electrician used to join the two wires, soldering machine and soldering wire. That soldering wire also made up of copper because it's a very good conductor. By heating that solder, they'll stick the two objects on a board, motherboard like. So in all these cases, you can see how solids transmit the heat from one end to another end by using the method called conduction, right? So conduction is the method of transfer of heat without actual movement of particles. Because in solids, the particles cannot move until unless you get the heavy temperature. Okay, different solids have different capacity. But generally, without movement of particles only, heat will transfer from one end to another end, where we have seen so many examples. Right? The next part is, second one is convection. You can see here, water. We fill the water and we are boiling. Suppose if you see in your house also, switch on the geyser or electric heater and observe. Observe carefully, you will get the bubbles. Why? Heat is first happens at the bottom. When you are heating any vessel also, boiling water in the vessel, when the heat flame will come, gas flame, it touches the bowl. So bottom portion of water will start heating. After heating, the bubbles will become lighter and they'll come up. Bubbles will coming up. Then cold part will go down. As the lighter particles will come up after heating, cold will go down. Starting initially, if you see, observe carefully, upper part will become very hot and keep inside, there won't be, it's not hot, it's cold only. Because still the heat process is going on. Once you supply the sufficient heat, total particles will start boiling and finally you get the hot water throughout the. So here what is happening here? Particles are moving, not like solids. See here. If you see in the vessel here, when you are heating, you can see the formation of, first you are heating with the light here. So bubbles will form like this. So all the bubbles will come to surface. And the water from surface will go down. Like the total, all the particles moves and changes their position. And finally they become the hot. So the convection takes place with actual movement of particles. Actual movement of particles. Whereas conduction, there won't be any movement of particles. But here, particles will move because they are become light in weight after heating. And finally, entire vessel, water become heat after some time. Such method of transfer of heat by actual movement of particles is called convection. The second method of transmission of heat. Water and air are proof of conductors of heat. Let us see how heat transfer takes place in liquids and gases. Take a beaker and fill it with half with water, as shown. Add some crystals of potassium permanganate, right? K2Cr2O7, chemical formula, right? To get the colors we can see now for green color to the water and heat it. Observe water in a beaker carefully. Stream of colored water move upwards from the bottom of the beaker and then move down. There is a complete, you can see the bubbles, colored bubbles, because we added the color here, potassium permanganate. Bubbles will move up like this and go down, and finally we can see all colorful bubbles. So just to observe carefully, instead of observing the normal bubbles, water bubbles, to observe colors, they add the potassium permanganate. When the water at the bottom gets heated and expand, the density of water becomes less after heating, because when you heat the water, the density becomes less. Hence, water becomes lighter and gets up to the top. Means bottom water will come up. water will go down. At the top, the cool water, which has more density, comes down. Thus, heat is transferred upwards by means of currents, movements. These currents are called conductional current. This way, the transfer of heat which takes place in liquid and gases is called convection. From the above experiment, we can conclude that a medium is necessary for convection. Conduction also requires medium, solid medium. And in a process of convection, particles of medium move from one place to another place. In case of conduction, we need the medium, solid medium, but there is no movement of particles. But in case of convection, there is a movement of particles. With actual movement of particles only, we are getting the momentum, right? So, when you see the applications, where this convection process is applicable, very interesting to see. Applications of convection: sea breezing and land breezing. When you see the near the sea or a beach, we can experience this. Daytime, nighttime, different temperature, quite different. Land and sea breezing are formed at a place near sea. Generally, this happens during the summer. In the day, the breeze or the cool air blows from sea towards the land. So there is a sea is there. After the seashore, we get the land. When you go to the beach, you can observe clearly. Summer, sea towards the land is called sea breeze. Means flow of heat from sea to the land is called sea breeze. At night, the breeze blows from the land towards the sea. Right? Say suppose this is the water, this is a beach. Here there is a land, shore, seashore. So morning time, what happened here? From here, heat will come here. Evening, the coolness goes from here to here. Right? Breeze flows from towards called land breeze. So lighter, it is rises up. Land breeze. During the day, the land breeze, the land heats up faster than the sea. Hence, the air above the land becomes lighter. It rises up and cool air from the seashore. Sea blows towards the land. That is sea breeze, called sea breeze. Morning, what happened? When heat is there, sunshine is there, the sand become more hot, right? So what happens? The hotness of the sand will go to the sea. It is called sea breeze. But night time, the same hotness from the water come to the sand. Like that, there is a mutual conversion, clearly given in the diagram. How the heat goes from sand to the sea and the sea to the sand. Day and night. That makes us to land breeze and sea. See, in summer, when you stand near beach place, sea, morning is very hot. Same time, evening is very cool. Right? That is the second part of the heat. Second part of the transmission of heat. And finally, radiation. Radiation, third part. So, conduction takes place only in solids. Convection takes place in both liquids and gas also. Radiation takes place even in the vacuum. For example, sunlight. How sunlight is coming from sun to the or earth? Because of the process called radiation. Right? Even it doesn't require any medium. It can, the method heat can transfer through even vacuum also. Like how sun is sending the sun rays to earth through vacuum. So why do you feel warm when we come out in the sun? As there is no medium in space, heat cannot transfer from either conduction or convection. The mode of transmission of heat in absence of medium is called radiation. Right? All the hot bodies, whether solid, liquid or gas, radiates the heat in all directions around it. When thermal radiation falls on the substance, some of it gets reflected and some other of it is absorbed. The temperature of the substance increases when it is absorbs the heat radiation. Right. So take two identical vessels of substance, ideal vessels, and paint the outer surface of one vessel with black and other surface with the other with the white. Two vessels you have to take. One you have to bottom portion with black and one is with white. Means which one absorbs the heat more you have to observe. Pour equal amount of water into the two vessels. The water is black vessel is warmer than the water in the white vessel. Thus, black body absorbs more heat than white body. Generally, in summer, we'll wear the white shirts, not black shirts. In winter, you can wear the black shirts because it absorbs the heat. Right. So, radiation is considered the fastest mode of transfer. The heat will reach from sun to our earth in only 8 seconds. See how fast it is transmitting. When you are seeing the convection, either it is a solid or liquid or gas, the radiation is very faster. The faster method of transfer of heat is radiation. Within seconds, the rays are reaching us. Okay. The final conclusion, we see what is the applications. What is the applications of radiations? We can see here, number one, the base of cooking vessel is coated with the black color is to absorb the more heat. Any cooking vessel, copper vessel, whatever it may be, coated with the black color. White colored clothes are comfortable in summer and black colored clothes are comfortable in winter. This is because white is a good reflector. It won't allow the heat to come inside. It is absorbs the less amount of heat. Black is the good observer. It absorbs the more heat of the heat and keeps our body warm. Simple. Wear white color in summer and black color in winter or dark color. Note, a good observer is a good radiator of heat. Hence, black is also good radiator. White, transporting highly inflammable substance like petrol, while LPG, etc. in tankers, the tankers are coated with the white color, which is good reflector of heat. Even thermoflask will use to store the hot water or coffee or tea. Also works on the principle of radiation only. Right? Thermoflask will come under example for this. Flask, and also we have the effect of heat. What is the effect we have seen already? Okay. Effect of heat. Heat will change the temperature of the body. Heat will change the size and shape. Heat will change the state of the body. It may be in solid state, liquid to vapor. When you keep heating the ice piece, what happens? Ice block is a solid. When you are heating, become water. If you further heating, become vapor. It is also comes under the effect of heat, which already discussed in the beginning only. Right? So some more is there. Change of state. That is called change of state. Some definitions are there. Where ice becomes water, the temperature is called melting point. When water becomes steam, it is called boiling point. Right? And whenever again come back to solid, when you keep the water into the fridge, it becomes solid. That is called freezing point. So whenever there is a change of state, we come across melting point and boiling point are substances. Melting is the point of temperature where a constant temperature where solid convert into liquid. Yes, constant temperature where liquid convert into vapor is called boiling point. And a constant temperature where vapor becomes solid or liquid becomes solid is called freezing point. Freezing. That's why keep in the, see here they are given the direction. Solid to liquid, liquid to gas. Again, gas to liquid is called condensation. You can, when you boil the water in the vessel, keep one cap. The vapors which after striking the cap, they come back again as a water. That is called condensation. Converting the vapor into liquid. And again, liquid into solid is freezing. We'll keep in the refrigerator. All these are the various definitions of the transfer of heat or transmission of heat or change of state of heat. All these you can come across the levels, these questions. Just once you go through the questions and try to answer them with the concept what we learned. So this is our total entire chapter. I think if any time permits, I'll show you one video for you before closing the class about the.
Friends, today we will learn the different modes of heat transfer. So let's start. Let's first learn what is heat. Heat is defined as the transfer of energy between two systems, and this energy transfers by means of particles bouncing into each other. So, we can say it is the transfer of heat energy from one object to the other object by means of the kinetic energy of particles bouncing into each other. When you bring two objects of different temperatures together,